the current, at least in the lower frequency range, because we're going to scan the frequency. We're going to run an AC test. We're going to scan the frequency. And then in the lower range, we could just see that that will be their parameters. So let's go ahead and do that. So I added a DC operation analysis and an AC analysis just to scan. And I ran this test, and let's see what I got. So first of all, I made sure that we can see that the inputs are 700. The inputs are 700, and the output is about 600 millivolts. So it's fine. And if I reviewed this list and made sure that all the transistors are in the operation point that I want, all this has nothing to do with what we're measuring. Now I know that I can measure the correct thing. So if we look at the GM test equal 1, we want to look at I out over V in when V out was 0. So again, I out was right here, and V in was the AC voltage on the operation point here, and the magnitude was 1 volt, and V out was 0. So that just simply is just saying if V in was just 1, so we're just measuring I out. That's all we have to measure. It's very easy. And if we look here, so we're going to measure I out for the GM test, and nice graph that in all the lower frequencies, it's basically 362 microamps, which is also the transconductance because it's 1 over V in, but V in is 1, so we can just change the units. And the curve here, the poles here, this is when really the AC effect of the box starts to apply, but we're not really interested in that because we're looking at the GM and lower frequencies in DC. So 362, let's try to remember that number. And then if I go and look at same for the R out test, then we just need 1 over I out, because if we go back to the equations, we just want V out is going to be changing. It's 1 volt amplitude, so it's just 1. So just 1 over I out is going to give us R out of the circuit. So if we go and look at that, we see that we actually have some nice number here. We got 69K, so 69 kilo ohms. That's pretty good R out for this circuit and the current that we applied. So we have GM, we have R out. Now the last thing we need to see that we actually have the right gain. So let's see the gain. So if I look at the open loop operation of the circuit, it's right here. We have some AC signal, and the loop is open. So we're going to be looking at the magnitude of this Y right here, op. So I've done that, and we want to make sure that GM test here was 1 because that's when the input is applying the signal and not the output. So let's just look here. We see that in DC it was the same as above, and in AC we get 28 dB. It's not so bad. 27.9 dB. That's the gain of the circuit. So now we need to see that our GM times R out is actually equal to 27.9 dB. So let's just go and run that in Excel. So we have we had GM R out. So we had, let's see, GM was, again, let's just get number 362. So we have 362 micro, and R out was about 69 kilo. So let's see, AV is going to be simply just this, which is about 25. It's not bad. Let's see, in dB, it's just going to be 20 times log. Sorry about that. 20 times log